Hi. Good morning. So we're going to talk a lot about a lot of core competencies, about what it means to protect data and the different mechanisms that we have across AWS to achieve that, including some ones that you may not be familiar with. And because you're not familiar with them, and your colleagues aren't familiar with them, and your leadership might not be familiar with them, there is an opportunity to do more. And that's kind of what the soul of this talk is about. It's to give you an idea of the range of things that are possible on AWS, but also to help share with you what we have known in our own practice and what we hear from customers is that the most important part about a security program is your people. And not just your people, but the set of norms and expected behaviors that you can have of one another, that they ought to have for themselves. So my name is Peter O'Donnell. I'm a principal solutions architect. I've been here for 9.5 years, and I've had the privilege of working with some of our largest and most challenging customers, including some exciting ones that were on stage this morning. And what we know is that this idea of culture can be hard to understand. What is culture? And I submit to you that this is why culture, that the purpose of culture is to eliminate renegotiation. And if you first hear that, it sounds a little funny. But what it means is that there's some standards, that there's expected norms and behaviors that you're done talking about. I mean, you're still going to have to talk about them to propagate them, but they're no longer in dispute. And if you go to the subway here in the West, you'll go down the right-hand side of the stairs. And if you visit Tokyo and you see their extraordinary subway system, you'll go down the left-hand side of the stairs, because that's simply what is done there. It's no longer a matter for dispute or readjustment. That it's this idea of a set of behaviors and norms that you must and expect stick with. And so at AWS, and we also encourage you to cultivate this in your own house, is that security is literally everybody's responsibility. And yes, we do have a sophisticated organization called AWS Security, but security begins with engineering. It begins with product definition. It begins in your support operations. I'm old enough to remember doing tech support in my younger days. Support might have an unusual level of access. That security is everyone's responsibility, and that you must build it into all layers of the stack. An opportunity to say, what could go wrong, and what am I going to do about it? And we call this behavior rigor, that you must do the work, that you must seek out these opportunities, these technical capabilities that we're going to talk about today, and apply rigor, understand them, match them to your controls objectives, and then set them up properly, and then observe them over time so that you know things are still working. If you've ever had a debate about preventative controls versus detective controls, well, the bad news is you still have to build the detective controls to understand that the preventative ones are working. And as you step through what we're going to get into here today, I want you to understand that good intentions do not work, but mechanisms do. And by building more and more mechanisms to implement controls and configurations, to have them right and safe and stay that way over time, that you can get really high quality outcomes. But I said it begins with people. At Amazon, we have this program called the Security Guardians Program. And what this really means is, how do we scale out AppSec, what we otherwise call proactive security? But how do you scale AppSec? How do you get everybody to become a security person? Well, I'm sure you've heard of train the trainer. I'm sure you've heard of, reaching your power users first so they can kind of cultivate it. Well, security works the same way. And this is how we've done it. and not everything we do is the right move for a customer, and you can make your own decisions, of course. But what we hear from customers who've adopted this model and have attempted to build it is that it works really, really well. That you can deputize folks and get security throughout your organization, most especially in your engineering and product organizations. I have had too many conversations with CISOs who tell me they're struggling, and they're describing a problem that really belongs to engineering, that really belongs to product, that those folks and the chief executive all have to believe that security is the top priority. And if you get this going, if you build some inertia, the expected benefits are titanic. They're really, really great. And not only are they good benefits in the context of like, oh, okay, this is more secure, but it's also good for your stakeholders across the company and maybe outside the company. If you have Sarbanes-Oxley problems, if you have board of directors and publicly traded company problems, if you have regulatory challenges, if you've got any kind of supervisory external stakeholder, that they want the same things as your security people, and that your compliance people also want those same things. And so we encourage you to build security not only into your products and into your technologies, but build security into your development teams. And you can move towards a place of continuous compliance and of compliance engineering. Well, if you think about what an SRE needs, she needs great observability, really good logs, repeatability, infrastructure as code, all that good stuff. Well, as it turns out, your compliance colleagues want the exact same thing. Your auditors want the exact same thing. And in the same way that I believe you should bring security into your builders teams, bring your audit people into your security teams and also into your engineering teams. Because truly it should not be an adversarial relationship. And I get that it often is. I've lived on both sides of that. But if you can get them in early, just like the security people, get them in early, you can have more productive and literally healthier, psychologically safer, nicer to go home at the end of the day of conversations with your colleagues. Because truly, you all want the same things. And so as you think about compliance, as you think about your engineering teams, bring them in early. We give you a lot of technical capabilities and possibilities to achieve some very critical compliance goals. And whether you're an engineering manager or security engineer or a software engineer or a compliance person, which I think probably describes about 80% of you, these are critical objectives. But again, you can obtain them through the same ways that you're doing all of the rest of your engineering and security work. So let's talk about some of the different dimensions of protecting your data. If culture is the foundation, what else remains? And I'm going to move through these quickly. There's a lot here. And there's a deep dive available on effectively all of these topics in separate talks. So we are going to move quickly. But these are kind of the classical dimensions. And of course, we make available a lot of great products and services to help you reach these goals. We also know that there's a long journey for protecting your data. That yes, you need to protect the data in the place it ends up. But again, if security is everyone's responsibility, that also means it's literally everybody's responsibility across different roles of infrastructure. Your edge team has a role, that your network team has a role to play. The people that administer the messaging buses and the queue systems have a role to play because there is a long life cycle here, and you need to be protecting data at every stage. So one of the classical overlooked ways to really get incredible value for ensuring certain things about your data that can only be accessed by your people from within your infrastructure using your credentials, and therefore not accessed by your credentials outside your infrastructure, not accessed by somebody else's credentials outside your infrastructure, not accessed by somebody else's credentials from within your infrastructure. The bad guy's going to bring their own creds to your house. And so we encourage you to reason about this idea of what's called the data perimeter. And we have a couple of key controls to affect this. And again, this is a story of cultural rigor. That you can't do one thing. You have to do a bunch of things. And that way, if one of them fails through malicious intent or accident, that you're not relying on one thing. We've called this defense in depth for a very long time when it was quite literally perimeter defenses, but this is also defense in depth by reasoning about different areas to apply controls and get high quality outcomes. So when we think about reasoning about your identities, reasoning about the resources that they connect to, reasoning about the networks that they're on, we give you really strong capabilities across the entire portfolio. And again, there are great deep dives on all of this. And we recently announced a new type of policy control called resource control policies. That is another way of adding belts and suspenders to data protection outcomes. So this idea of the data perimeter can get really high quality outcomes, that you can apply policy to your resources to ensure that they're only accessed in ways that make sense. And what you see here is that it must be coming from a credential that belongs to me. AWS Principal Org ID, that is to say a credential issued by my own AWS universe. This prevents the adversary or a too eager developer from bringing in their home credentials and attempting to use them within your infrastructure. Same idea on the network. We're going to allow using an endpoint here only if it belongs to me. Only if these creds belong to me. Here's another example. On the resource. Okay, you can put a message into this queue, but only if it's actually my queue. Belts and suspenders all the way around. And here's another example, right? So we want to stop somebody in the coffee shop from accessing your bucket directly. S3 buckets are locked down by default, of course, but your teams might be able to mutate some of those policies in ways that you don't find acceptable. So, data perimeters. Again, deep dives available. Search online for that phrase, incredible content available to you. Encryption, another classical way of protecting your data at rest. If you get your crypto from us, we're on it. And we have really high quality crypto and a world-class team that is building those tools. And we provide both data at rest and data in motion for all of the AWS services that store and process data. We've recently completed some big milestones regarding data in motion. We now support TLS 1.3 everywhere. TLS 1.3 is really important. TLS 1.3 is not only better and safer, it is also faster for first encrypted byte. It is way faster for first encrypted byte if the server and the client have already met. That's a big deal. Drains tail latency out of your remote use cases. So we encourage you to adopt TLS 1.3 for a couple of different reasons. This idea of encryption on AWS, you can do client-side encryption. We provide open source SDKs. We have a really great open source SDK for client-side encryption with Dynamo that gives you searchable encryption, which used to be an insane fantasy. And we apply encryption at lower level infrastructure that you don't see or even smell, but it's there anyway. All of the networks that connect AWS controlled facilities are themselves encrypted at a lower level. Cross-region VPC peering implements its own encryption. So if you put a TLS connection over cross-region VPC peering, there's literally like 4 different layers of encryption for that stack. And so we give you some really great tools. KMS is the right place to get that. KMS, you can do a lot with policy control and get very clever. That is an advanced use case, but definitely be using it. Definitely be using it. AWS IAM, of course, is where credentials and login comes from, but you can now enter into IAM using an X509 certificate. So if you already have a lot of cryptographic identity in your world, PKI, you can use that PKI infrastructure to assume roles. Of course, we have certificate products. And again, rigor in your certificate products. Figure out the right pattern for this. And I'm old enough to have taken a couple of pages in the middle of the night from expiring TLS certificates. Well, if you use ACM integrated with ELB, you'll literally never have that problem again because the system just does it for you. Really, really powerful stuff. But we know that there is a shadow looming for contemporary cryptography. And that shadow is this idea of the possibility of a sufficiently powerful quantum computer coming into existence. And cryptography is predicated on a set of assumptions. And with asymmetric cryptography, one of those assumptions is that it's super hard to factor a prime number. if a powerful quantum computer comes into existence, it will no longer be super hard to factor primes. This breaks an underlying assumption. So there is kind of an interesting long-term threat for certain customers. That there's this idea of an adversary harvesting ciphered traffic today, keeping it in the freezer for gosh only knows how long, 10, 20, 30, 100 years, no one's quite sure. But if they get these new capabilities, they may be able to attack the stored cryptography. So this means that we have to deal with the problem today, because it takes a long time to build new standards. It takes even longer to get those standards like ratified and fully vetted. Because if you create a new standard that is survivable for a post-quantum future, you don't want to be vulnerable to classical attacks either. But the good news is the industry and Amazon itself have been working on this for a very long time. And we now have the selected crypto modules that will be used to support this idea of a post-quantum future. And Amazon will be migrating to those over the next 5 years. And if you get your crypto from us, that is to say ELB, CloudFront TLS, things like that, we will be ready before you need it. If your core product involves crypto, in other words, not just TLS on your website, but if there's something cryptographic about what it is you do, maybe you're signing firmware, maybe you're signing firmware for assets that have a long lifetime, then this is something you need to start worrying about. But generally, if you get your crypto from us, we're on it, and we'll be ready before it's necessary. We've got a really great blog post coming out this week, so remember to search online, and that blog post has a complete view into where we are and where we're going for PQ. We support some interesting PQ stuff today. So if you're moving files around using the transfer family, which is basically managed SFTP and managed SCP, you can get PQ algorithms there today. There's a shared responsibility model here. I said we'll be ready before you need it, and that's on us. But you need to build the muscles of replacing your software and updating your software. This is a muscle you need anyway. This is a capability you need anyway. You need software inventory. You need the ability to rapidly release changes and updates to it. And you're going to need it again in the future, in the next 5, 10, 15 years, to prepare yourself for PQ. The good news is there's a reason to do some of that work today, and that's TLS 1.3. PQ algorithms and support for PQ, post-quantum is what I mean every time, is not going to come to TLS 1.2. So there is already a good reason to go do that work, to get onto 1.3 and prepare and again, build those muscles if you don't have them, to ensure that you know how to inventory your systems and how to, rationally and at scale and with high levels of assurance, replace some of that software. Because you will have to replace the AWS SDKs and the CLI, and you'll have to update your browsers. And everything else that speaks TLS that you want to start using PQ, the client will need to be updated. We're on it on our side, but just because our load balancers support a PQ algo doesn't mean you're ready to take advantage of it. But when you are ready to take advantage of it and your clients begin what's called advertising to the server, the way TLS works, the client kind of says, I'm willing to do the following things, and the server says, so am I. If your client says it prefers PQ, we will immediately support it. And again, that's over a horizon over the next several years. Let's talk about observability. Observability fits into a lot of the dynamics that we're talking about. I mentioned earlier this idea that you still need detective controls if you build preventative ones. And you need to know that things that you expect to work, particularly the things that map directly to security outcomes or compliance outcomes, you need to know that they're still happening. And you can do that with AWS services, whether that's CloudWatch being able to ingest your logs, CloudWatch being able to ingest your metrics and synthetically create new metrics is one of the best features in the product. That is to say, you can observe how many times a certain event happens, how many times another event happens, turn those into numbers, and then observe a ratio between those events. Event 1, 2, 3 is only really bad if it's more than 20% of event 3, 4, 5. CloudWatch lets you do that, and that has enormous security outcomes, right? It's bad to see failed SSH attempts. It's even worse if it's the majority of the connections. And you could build really high quality observability using some of the AWS services. CloudTrail, of course, is the journal. You need to be using your CloudTrail. Yes, you need it for after the fact forensics if something bad happens, but you can be using CloudTrail as a source of information and signal to improve your operations, to understand your development and deployment patterns and observe them over time. And you can use that rich data to, again, improve your operational excellence. And improved operational excellence, of course, leads directly to high quality security outcomes. So one of the inspirations for this talk originally was a story I heard a long time ago from a customer, and they were very proud that they had gotten taxpayer ID, social security number, out of their call center application. So a year later, they wanted to do some natural language processing on comments that the agent might put in. Very cool. A year later, they start using one of our data detection products, Macy, which can help scan your S3 resources and the data to see like, oh, are there credit cards in this bucket? Are there social security numbers in this bucket? And this customer was shocked beyond words to discover that there were social security numbers in their unstructured data pool from the call center. How did that happen? Well, when they took the field out of the little form that the call center agent's using, they thought they had solved the problem. But all that had really happened is that the social security number started going in the comments field. And they were, unfortunately, in a position where they had polluted a downstream data source or downstream data repository, lake or warehouse, whatever, with SSNs, even though they had no idea. Should have never been there. So I mentioned earlier this idea of really doing the work in understanding where you can apply rigor and security at every step and every layer. So in a modern distributed system, there's a lot of messaging buses where one component is calling another. If you're using AWS, one of the best ways to do that is through SNS, the simple notification service. It's this ubiquitous messaging bus that you can build software that puts messages in, you build software that gets messages out. It's awesome. It does exactly what it says on the tin. And SNS itself has the ability to detect PII. Now you may have other places that you're using to detect PII, but this is another example of this cultural obsessive rigor that even in the messaging bus, there's an opportunity to police and detect unwanted data in those streams. And it's not only supported in SNS, it's also in CloudWatch. Why is it in CloudWatch? Well, there's this idea called a log spill. And log spills are scary and terrible. Because again, I need to protect my customer database. Sure, obviously. But as it turns out, there are other places in your operating environment that might become polluted, as it were, with data that shouldn't be there at all. And if you've got a developer that turns on the wrong debug flag for a web application, all of a sudden you've got query strings in your logs. And those query strings might have customer confidential or company confidential information in them. So as you bring data into something like CloudWatch Logs itself has the ability to detect things that should not be there. It's a really, really powerful pattern. And another example of the rigor that is required to do the work to get the high quality outcome. So this is what these kind of look like, this idea of a data protection policy. And again, this is available both in SNS and CloudWatch Logs, two services that might not be on your radar when it comes to protecting data. But as it turns out, it's a really important part of ensuring a high quality and compliant and assured and audit-proof way of managing your environment by applying rigor and deep ownership across everybody. That the people on the log ingestion system might not think that protecting customer data is their job. Because why would it be, right? It's just a log system. But as it turns out, again and again, security must be everyone's responsibility. So we have some managed identifiers for this. So you don't have to invent regexes until you grow old and retire. We've got built-in capabilities into these detective features of SNS and CloudWatch logs, where we will automatically kind of know these things and provide them to you as features for no additional charge as part of the core product. And again, there's really good benefits here, right? That this scales well because it's part of the fabric of the messaging service itself, and that you get really good visibility into it. And this, again, it answers two questions. Not only making sure things are working correctly, but also being able to attest to your boss, to her boss, to the audit boss, whomever, that look, how do you know there's nothing in that? Well, three ways. Number one, up at the front end of that, we made sure it was never going in. Number two, in the flows between them, we made sure it was never there. And number three, in the back, we were scanning that data as well. Belt and suspenders, multiple controls, so that you can still get the high quality outcome, even if one of the controls and one of the technologies fails. Again, either through malicious intent, God forbid, or just through a misconfiguration. So I want to bring up to the stage a dear colleague of mine, talk about everybody's favorite topic these days, generative AI. Ram and I have been working together for a long time, and I leave you in very good hands.
All right. There you go. Cool. Thank you, Peter. Hey, everyone, and I'm Ram Ramani. I'm a Principal Security Solutions Architect at AWS, been here about 8 years. So we're going to be continuing the rigor conversation and talk about protecting data within your generative AI applications. So when you are trying to build applications powered by generative AI, you have multiple personas participating. You have applied scientists, you have data scientists, developers. Applied scientists are building models, data scientists are probably prepping data or preparing data sets, and you also have developers. It's, Peter talked about the distributed security ownership model, and it's important that all of these personas are collaborating and putting on their security hat, as well as collaborating with security humans to make sure that they bring the rigor required to build a secure application powered by generative AI. So just show of hands, how many of you are actually building generative AI applications within your organization? A few of you? Great, all right. So we will kind of use these terms during the presentations just because many of these terms have different definitions, so I just want to make sure that I lay it out there in the beginning. So we talk about tokens. These are usually words or part of words. When I say mask or sanitize, I'm referring to replacing data with an identifier that does not have any relation with the original data. And when we say guardrails, we're talking about methods that provide safeguards to prevent undesirable behaviors. And when I say RAG, I'm referring to using organization data to improve quality of model inference. All right, so we're going to start with 3 assertions. And I want to take you through this section. At the end of it, we will define whether these assertions are true or false or debatable. The first one being, I should use guardrails when building an application powered by generative AI. The second one, I need to consider authorization for data used by generative AI processes. And the third one being, I need to sanitize data before it enters generative AI processes. And we'll look at each of them as we go along. I'm sorry, I think. So some key definitions. When you're building a generative AI application, the risk here is that the possibility of an adverse event with consequences on any dimension of responsible AI. And for security, it is an exposure to a threat that can compromise the confidentiality, integrity, and availability of an ML AI system. And from a privacy perspective, you're looking at the exposure or mishandling of sensitive or personal data in the context of an interaction with an ML AI system. So you probably have access controls for your data within your organization. And you may already have such granular classification as shown on the screen, but you may decide that some of these data types may not enter the generative AI processes as you build your application that is powered by generative AI. These, as you can see, traditionally, many organizations have high-level classifications, but with generative AI touching code and many other data types, all of these classifications become very relevant. Expanding on data types, we find that a large percentage of data within organizations are unstructured, but when customers are building applications powered by generative AI, they're using public and private structured and unstructured data for their applications. Now, building generative AI applications brings new challenges. And these are broader challenges related to responsible AI, such as undesirable and irrelevant topics being surfaced, toxic language that can harm or have risk for your brand, organization-sensitive data exposure or being exposed or being out there with an adversary, and then bias or stereotype propagation. In this section, again, we're going to be focusing on data protection or sensitive data exposure. So let's take a look deeper into the data risk with generative AI. So when you're building an application powered by generative AI, you have prompts, you have unlabeled data for continued pre-training for your models, you have labeled data for fine-tuning your models, and then you have structured or unstructured data for RAG or by agents, and then maybe you're building your own model with your own training data set. All of these are entering your models. It could be either a model that's powered by Amazon Bedrock, or it could be a SageMaker model that you build, or a third-party model, and a response goes back to the user. So you need to think about the associated data risk for any of the data that is listed here. Now, sensitive data can be part of prompts that are coming in, as well as in responses, and you should think about sensitive data exposure risk for both internal applications that your employee may be accessing, as well as external customers that may be accessing an application that you're offering over the public internet. Let's talk about model fine-tuning. So when we have labeled data that is entering a fine-tuning process and eventually operating on one of the model types, leading to a model which is fine-tuned, which has increased accuracy for specific tasks. So when you're fine-tuning a model with a small number of labeled data, this data needs to have proper access control so that it's not poisoned, as well as you want to think about least privilege. Only the fine-tuning process has access to the labeled data and nothing else, right? Now, when we talk about RAG or retrieval augmented generation, a user is, in this context, interacting with a chatbot application, and the RAG process is using data within your organization to eventually generate a context which gets appended to a system prompt and a question that is sent to the model, which then generates a response back to the user. And even in this, when you think about RAG, you need to think about, hey, I have this data which is internal to my organization accessed by this retrieval process. Should I sanitize it? Or do I need to think about access control for this data? And we'll look at these in more detail later. So let's break down this conversation into a few use cases that we will talk about and study the risks and mitigations. The risk here is that the model that you're using in your application powered by generative AI may reveal sensitive data about your company. And what protections have you built to safeguard against this risk? Now, let's reason about this risk with an analogy to driving cars. You want to drive fast and have the best user experience or driving experience while you have a guardrail that protects you in case something goes wrong. And that's why we built the Amazon Bedrock guardrails. And it's a method for you to implement safeguards tailored to your application requirements and responsible AI needs. It could be about preventing hallucinations, it could be about sensitive data exposure, it could be about denying specific topics that is harmful or you think it's not appropriate for your customer base. And typically all of these dimensions that are represented here in the slide are evaluated in parallel. But we are focusing here on the dimension of sensitive data exposure. When I say that this is all evaluated in parallel, the reason being that it is absolutely critical that any of your users that are using your application powered by generative AI, they have absolutely as low a latency as possible. And that is why all of these dimensions are evaluated in parallel when you are building an application powered by generative AI. Now, with respect to Bedrock guardrails, they can work with models supported by Amazon Bedrock, or on a model that you have built using SageMaker, or on a third-party model. These are independent guardrails, right? And these guardrails invocation do not need model invocation. You can apply guardrails without model invocation, and the guardrail invocation itself can be within a Lambda function or a container application or any other stack that you have built. It's, after all, it is a RESTful API that you're calling to apply guardrails for the filters that I showed you. So let's look at another use case. The risk we're talking about here is your sensitive organization data is used by the RAG process, or the retrieval augmented generation process. The question you need to ask are, do I need to sanitize the data that enters the RAG process? Second, what mechanisms have I built in my organization for the retrieval process so that only authorized documents are retrieved for the requesting individual? This kind of gets into least privilege, and let's take a look at how this works. So you have a user, Alice, asking a question of a chatbot application, and the retrieval process in this case is identity aware. So it's able to check whether Alice is authorized to access organization data that you're using for the RAG process. And then if she is, there's a context that is generated which gets appended to the system prompt and the question, which then gets sent to one of the models. And if not, there is no context generated, and only the system prompt and the question gets sent back to the model. And then the response goes back to Alice, but before it goes back to Alice, it's filtered by the guardrail configuration that you set up. On a similar vein, if your retrieval process is not identity aware, you can orchestrate identity awareness using agents. So you'd be able to take, in this case, Alice is again interacting with a chatbot application, and an AI agent is checking if Alice is authorized, only then gives the green signal to the retrieval process, which does not have identity awareness, to then go and generate the context based on similarity search or based on the question that is asked, and eventually leading to a response that's again filtered by the guardrail before it goes back to Alice. So let's dig a little deeper and look at fine-grained authorization. What we spoke so far is like coarse-grained authorization from an identity perspective, but let's look at fine-grained authorization. You can see here that a name is replaced with a placeholder, similarly for email. But in the case of credit card, what I'm doing is I'm replacing a few credit card digits with star, 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 which is, again, these are all non-reversible. But some of you may want to have fine-grained authorization and reversibility or re-identification of specific data for an individual or a group of individuals. In this example, I'm replacing a few credit card digits with an encrypted block, encrypted with an AWS KMS key and a key reference for reversibility. So let's take a look at how this works in the context of generative AI. So we talked about reversible masking, and in this case, Alice is again interacting with a chatbot application, which is with a retrieval process that is identity aware, and that retrieval process is checking if Alice is authorized. If yes, it generates the context, which is appended to the system prompt and the question. But then there's another process which is masking it and generates a masked context, and the masked context is basically using KMS to mask some of the credit card data that I showed you on the previous slide. And then in the response from the model, there's the guardrail is applied for the responsible AI policies that you may have. But then before it goes back to Alice, because in this case, the example is that Alice is authorized to look at the full credit card number in plain text, the part of the credit card number that was masked is reversed before it's sent back to Alice. The way this works with KMS is that the KMS has got something called key policies, and what this is showing you is that if Alice is a principal within the key policy and she has decrypt permissions, we are able to unmask the data or the part of the credit card number for Alice before it's sent back to her. So this is kind of giving you a method to build fine-grained authorization within applications that are powered by generative AI. Now, this is not new to generative AI. However, in the context of tokens in and tokens out, these mechanisms are desirable, and we have seen that many healthcare and financial organizations are asking us about financial, like a fine-grained authorization that they can build within their applications that are powered by generative AI. All right, so the third use case I want to talk about is your organization-sensitive data may be used for fine-tuning your model. The questions that you're asking is it necessary to sanitize the fine-tuning data if protections such as guardrails are applied in downstream use of the fine-tuned model? And also, do you need to evaluate the fine-tuned model accuracy after sanitization? Kind of this is debatable. And the debate is mostly around centralized versus decentralized governance models. And I want to kind of bring back what Peter said earlier about rigor and collaboration and distributed security ownership. If you don't know that the downstream users of your fine-tuned model are using protections such as guardrails, then you're better off sanitizing the data. But if you don't sanitize, then you will need to have stronger governance of downstream protections such as guardrails. We recommend, however, that you should use guardrails, regardless of whatever design you're pursuing. But there are use cases where you may want to follow a very tight data minimization strategy by sanitizing data before it enters the fine-tuning process. Now, let's say that you decide to sanitize. You will have to measure the effectiveness of the fine-tuned model for your user experience, and such that, and you want to check whether sanitizing increases accuracy and provides a better user experience or not for your application. Model evaluation is critical, and having a pipeline for model evaluation that works very well is absolutely needed, even with guardrails and any other protections that you may apply. And as you can see, these processes such as fine-tuning are probably pursued by applied scientists. They need to think about identity-based authorization and sanitization, which are all related to security. So the distributed ownership model as well as the rigor and security is absolutely critical as you have your organizations or your teams pursuing building a application powered by generative AI. So let's look at one last use case. So the risk I want to talk about here is sensitive data may still be revealed with all the protections that I talked about. So essentially, you're looking at protections such as guardrails, identity-based authorization, and even sanitization, masking, reversibility. With all of that, is it possible that your application still can reveal sensitive organization data? And I want you to bring your attention back to rigor again, because you need to have a rigorous red teaming process that employs fuzzing with prompt mutations within your model pipelines to look at possible vulnerabilities or jailbreaks that can lead to sensitive data exposure. So again, the culture of security and distributed ownership can really help here in going a long way to build a secure application that is powered by generative AI and improve the user experience for your customers. All right, so let's get back to the assertions I started this section with. First one was I should use guardrails when building an application powered by generative AI. The answer to that is true. I need to consider authorization for data used by generative AI processes. Again, true. And third one, I need to sanitize data before it enters generative AI processes. That's kind of debatable because of the governance models that you may choose to pursue. So, cool. So that's all we had for you. And I want to kind of summarize by talking about the key takeaways here. So Peter talked about the importance of culture and distributed ownership for better data protection. We then talked about protecting your data perimeter with all the tooling and the mechanisms that are available with policies. Please do consider implementing them. They are available today for you to use. You want to start preparing for the post-quantum world. We have made it easy for you to experiment with some of our libraries such as S2N and AWS LC, as well as with some of our services that you can actually initiate a TLS handshake with a post-quantum key agreement. Try it out and see if that's something you want to pursue within your organization, and also start thinking about inventory. Observability and log protection is necessary. Again, take advantage of all the tools that are available in AWS. And lastly, think about the risks and trade-offs when you're building applications that are powered by generative AI. So that's all. Thank you so much. Lastly, our LinkedIn profiles for me, Ram Ramani, as well as Peter O'Donnell is here. We are available outside the room for if you have any further questions and you want to come and talk to us, and happy to take any questions and help you. Thank you so much. Yeah.